Well, hello, Math 1 students. Let's get started on our review for Unit 5. This is the last unit review for this semester. Just a reminder here, I really hope you'll make use of the pause button. You don't want to just practice copying down what I do, because that's going to be very, very limited in its helpfulness for the test. What you want to do is use this as a check against your own work, so you can use it to correct, and also maybe as a way to give yourself a hint if you get stuck. But only play this as long as you need to get that hint, and then work the problem yourself. All right, we have start off with a graph of two different systems, and you're asked to look at the graph, write the equations, and then compare what they mean. So, company G, company F. For company F, we're going to look at the line f of n here, and notice that our y-intercept here is 6, and our rate of change is there to there to there. So it looks like we go up and right. So going up is positive number. Now, watch carefully, or notice carefully, that it's not just up 2, right? It's up from 6 to 12. So this is an increase of $6 dollars earned for every 1 hour worked. So 6 over 1. So this is 6 over 1, or just 6. Now this says f of n, so it's a function of n. So we should have 6n plus 6. We could write just this 6n plus 6. I'm not a stickler for this at this point, as long as we're writing the slope and y-intercept correctly. So if you put x instead of n or something like that, I wouldn't sweat that. For company G, you see that it starts at 18, so that's our y-intercept, and then it goes up just, let's see, looks like 2 squares, so that is from 18 to 24, so that's 6. But instead of over 1, it's over 1, 2, 3, over 3. So this one, 6 over 3 is 2. So 2n plus 18. And our solution to our system is right here. This is the point where the hours worked and the amount earned are identical for both companies. That's 3 hours worked and $24 earned. So that means we've got a solution of 3, 24. Now, when will you make more with company G? Well, here's the line for company G. So more is here. It's where the line from company G is greater. So that means we're asking when. That means at this point, at 3 hours, before then, company G is the better one to go with. After that, after 3 hours, you can see that the line from company F is higher. All right, next one. Sprint has an activation fee and costs $45 per month. So an activation fee is the y-intercept. $45 per month would be 45x. So we're saying the cost of Sprint, right, y, is this. For TracFone, the cost is $65 per month. So here's the per month. And no enrollment fee, so we don't even have to add a plus anything. So now we're saying, when are they going to be the same? So when is the cost of Sprint, which we find by adding $50 to the $45 per month, when is that going to be equal to just the plain old $65 per month? So now we have an equation to solve for. Subtract 45 from both sides. We've got 50 equals 20x, and then divide both sides by 20, and we have x equals 2.5. So 2.5 months in. At that particular moment, what was the cost going to be? I can use either of my original equations, but I could say y equals 65 times 2.5. $162.50 is the cost. So after 1 year, that's 12 months. This is a typo. Fitness Center A, that was from a different version of this question, but this is going to be Sprint and cost of TracFone. So Sprint and TracFone, each of these we're talking about 12 months. So what's representing months here is our X. So with Sprint, it's going to be 45 times 12 plus 50. So that's $590. And our cost of TracFone is going to be 65 times 12. $780. So you can see at 12 months, even though you have to pay an initial fee with Sprint, it's definitely the better deal. All right, number 3. There was a typo on here as well. The numbers are really kind of weird if we don't fix this. So this should be not a total of 180, but 130. So the work crew hires 2 assistants. The first day, his senior assistant works 8 hours, and his junior assistant works 5 hours. So we know how many hours they work. We don't know what their rate of pay is. So this is going to be 8 hours times a certain number of, or times a certain amount of pay. That's the senior assistant. And the 5 hours of the junior assistant times his rate of pay. So they're going to be different, equals 150. The next day, we have 4 hours of the senior assistant and 8 hours of the junior assistant, and that costs 130. Well, these aren't directly comparable scenarios, right? We've got 8 and 5 and 4 and 8, so that makes it harder for us to compare them directly and intuitively. But we could say, well, what if instead of 4 and 8, what if we just said, let's double that? Then we'd have 8 and 8. And then we could say, okay, we have the same number of hours that the senior assistant work. We could just take that out of the equation. All we'd be left is the difference in hours of the junior assistant and the difference in pay. So that's what we're going to be doing here. Let's multiply this second one by 2. However, I'm going to suggest that we multiply this by -2 so that when we're finding the difference, we've already got the subtraction built in. So -8x minus 16y equals -260. Then I'll copy this other equation down. And I've got -8x and +8x. Those cancel out. -11y. And let's see, this is 26 minus 15 or 16. This is -110. Yeah. So then we divide both sides by 11. And that means y, the junior assistant, makes $10 an hour. For the senior assistant, we need to figure that out by plugging that back into an equation. So let's say 8x plus 50 equals 150. Right, we take the 10, we put it in for the y. 5 times 10 is 50. So if that junior assistant was paid for 5 hours, on the first day. That means he was paid for $50. He was paid $50. So 10 times 5. And that means that there was $100 that was the payroll of the senior assistant. So that means the senior assistant made $100 in the 8 hours. So what does he have as a rate of pay? 100 divided by 8, $12.50. All right. Now here we're given, it's not a context, it's just a set of equations. We need to solve it. You can see that the x's don't match up, so we couldn't just subtract them and eliminate them as is. The y's don't match up. We can't just subtract those. And 5 is not a multiple of 4, and 3 is not a multiple of 2. So that means that we can't just multiply one equation. This is one of those where we have to multiply both equations. So I'm going to just choose, and you can choose either one, but I'm going to choose to solve this by getting the y's to match, the y coefficients to match. So let's multiply this top one by 3. 15x plus 6y equals -3. Now, why did I choose 3? Well, I'm looking at both the y's and saying, look, if I change them both into 6y, then 3 will go into 6 and 2 will go into 6. That means I can multiply them both to get 6. And if they match, then that allows me to cancel them out. So I'm going to multiply this one by 2. Now, if you've been paying attention in the last few days in class, you remember that we started to work with negative numbers. That makes our subtraction easier. So I'm going to make this times -2. It becomes -8x minus 6y equals -18. So that means these cancel out. And because I already built that negative in, it's maybe a little bit more straightforward in just combining them. So I've got 15 minus 8x, 7x, and -3 minus 18 is -21. So we divide by 7, and x equals -3. Almost done, but not quite. So we need to take -3, plug it in for one of these original equations. 5 times -3 plus 2y equals -1. So let's add 15 to both sides. And we're going to left with 2y equals 14. Divide both sides by 2, and y equals 7. All right, there's the front side. Let's turn over to the back. Now, we're given another system of equations to solve. You'll notice that this system of equations, that's not the same form of equation, right? Number 4, we had x plus y equals number, x plus y equals number. So it was really set up well for elimination. This one's not set up that well. We've got an x equals, and then we've got a -2x minus y equals. Now, it is possible for you to solve these using the elimination method. Right? We could make them look like each other, add 4y to both sides, and then multiply by 2. That's possible. But it's also set up for substitution pretty well. So I could say, since x equals this, I can take this, what x is equal to, and put it in for where x is in the second equation. So that becomes -2 times the thing that x equals minus y equals 17. This becomes -2 times -4y plus 16. Now we've substituted that in. After we do that, it's a matter of simplifying and solving. So we've got a -2 outside of parentheses. We need to distribute that to everything inside the parentheses because they're added together. So this is -2 times -4 is 8. Whoops, not -8. So 8y minus